Hello everybody, in this video we are going to continue our conversation about how to simplify radicals, or in this case how to simplify square roots. So in the previous video we talked about what a perfect square is. We also talked about how a square root undoes a perfect square. We made our list of perfect squares up to 15. And then we looked at a couple examples on what we need to do and what we need to look for in order to break these down. So let's go ahead and jump into these examples right here, which are very similar to the ones we did in the previous video. The only thing that I am going to point out is that these examples have a number or a negative on the outside of the square root. So that just kind of adds an extra step at the very end. But we can't forget that those numbers in the front are still part of our problem. So let's go ahead and start with the square root of the negative square root of 72. So the number that we're going to focus on is the 72. We need to make sure it is not already a perfect square. So if you look right here, you go back to your list that we have created and notice that 72 is not in this list. So because it's not a number that is already a perfect square, we actually have to break it down. Now I do want to remind you, anytime we have a negative that's just kind of floating out there, remember that there's actually an understood 1 there. So I'm going to go ahead and put it there for reference. There's a -1 outside of the square root. We actually won't do anything with that -1 until the very end. So I'm going to ask you to ignore it, pretend it's not there, and break down the square root of 72 like we did the other problems. So with this one, we're going to take 72, since it's not a perfect square, and start it off with 1 times 72. Now I do kind of want to show you a little bit more in this video the process that I'm using. So if you do have your calculator in front of you, let me show you a fast and easy way that you can generate that list of factors of 72. So I'm going to grab my calculator here, and we already have 1 and 72. So I'm going to take 72 divided by 2. And notice that it goes in 36 times. So that lets me say 2 times 36 will give us 72. And so my process is just to go through all the numbers. So that was 1, 2. Let's do 72 divided by 3. Gives me 24. 72 divided by 4 gives me 18. 72. Now I know 5 will not divide into 72, but I want to show you what will happen if you do divide it by a number that is not a factor. So if I divide by 5, notice it gives me a fraction and not a whole number. So anytime it gives you a fraction or a decimal, that automatically tells you that number is not a factor. Skip it. So in this case, we went all the way to 4. We're going to skip 5 and we're going to try 6. Notice that I get a 12, so we know that 6 times 12, 72 divided by 7, does not go in. 72 divided by 8, 8 and 9. So the reason I like to do this in this particular order is because this allows me to stop. Notice that the next number after 8 is 9, and 9 is already on this list. So by going in order from 1, 2, 3, 4, that keeps me from missing anything that is a factor and jumping around and hoping that I get all of them. So this actually gives you a process to keep everything very organized and from having to skip a factor in there somewhere. So because 9 is already on the list, that lets me know that these are the other half of the numbers. So we're actually good here. So from here, we're going to separate, replace the 72 with one of these factors. So I'm going to remind you that you might run into multiple perfect squares in this list. We want the biggest one. So as you're looking at this list, identify all the perfect squares. And if you forget which ones they are, look at your list and find the biggest one. All right, so I automatically see the 4. I also see the 9. But before you focus on either the 4 or the 9, look one more time through the list and you're going to notice that 36 is also here. So 36 is going to be the biggest perfect square. And in order to get 72, it's going to be 2 and 36. So when we write this down, go ahead and bring down the -1. Draw your square root. And because 36 is our perfect square, we're going to write it first, times 2. All right, from here, we're going to keep this -1. We're going to do the square root of 36 times the square root of 2. And we know that the square root of 36 is 6. So if you go back to your list, or you can also type it into your calculator. So you can hit Control X squared, type 36, and notice that it tells you it's 6. Now, when you break down the square root, notice that the 6 does not have a square root around it. So when you type it in, it's just a 6, not the square root of 6. So we now have this -1. This becomes 6. And then the square root of 2. So even though it looks like I ran out of a little bit of space here, I'm going to go ahead and write it underneath. Because these both numbers are on the outside, we can actually multiply those two numbers together. So -1 times 6 gives us -6. And then we can bring down the square root of 2. Now the square root of 2 cannot be simplified because 2 is not a perfect square. And no perfect square divides into 2, so we can't break it down any further. So you're going to notice that there's very particular numbers that will never break down. So square root of 3, the square root of 6, and now the square root of 2. Those are going to be the numbers that you definitely need to look at when you're trying to break this down, because once you have that, it can't break down any further. All right, let's look at this one right here. 32 does not have that many factors, so let's go ahead and jump into that one. So we're going to start off with 32, 1 and 32, 2 and 16. 3 does not divide into it, but 4 does. 4 and 8. 5 does not. 6 does not. 7, and then 8 is already on this list. So if you're going at it in numerical order, then just kind of follow through until you hit that number once again. All right, so from here, let's look for our perfect squares. We know 4 is a perfect square. 16 is a perfect square. 16 is bigger, so we're going to use 2 and 16. And don't forget about the 6 in the front. Even though we're not going to do anything with it at the beginning, we're going to do it at the end. So keep on bringing it down. So 16 times 2. Then we say 6 square root of 16, square root of 2. The square root of 16 is 4, so we have 6 times 4, square root of 2. So because these two numbers are on the outside, we're going to multiply them, and it's going to give us 24 square root of 2. And 2 cannot be broken down any further. All right, so what I'm going to ask you to do is go ahead and take a moment to pause the video so you can try -5 square root of 18. Once you finish working it out, you can unpause the video. So go ahead and pause right now. All right, so hopefully you guys had a chance to work this problem out. Let's go ahead and talk about it real quick. So 18 is not a perfect square. So we said 1 and 18, 2 and 9, 3 and 6. And then those are all the factors for 18. The only perfect square in this list is 9. And so because it's the only one, we're going to go with 2 and 9. So I'm going to start off with 9 and then the 2 underneath the square root. We're going to split it into 2. So we have the square root of 9, the square root of 2. And notice that we're bringing down this -5. And once you take the square root of 9 and get 3, then we get to multiply -5 and 3 because they're the numbers on the outside, which gives us -15 square root of 2. There you go. So we're going to go ahead and pause right here. Hopefully looking at these examples and working through them is starting to make a little bit more sense how to simplify these square roots. But we do have special square roots that we're going to look at next. And then we're going to look at some expressions that have square roots in them and how we're going to go about simplifying those. So with that being said, let's take a pause right here and I'll see you guys in the next video.